Good afternoon, everyone, and welcome to today's session on deep learning. Good afternoon, Padmavati ma'am. Ma'am, I have given you the right so that we can start with the session.
Sakshi, we will be starting.
Okay.
Is my screen visible? Am I audible?
Yes, ma'am.
Oh, thank you. Okay, let's start today's session on deep learning. In the last class, we have discussed about architecture, CNN architecture, and most widely used architecture, that is AlexNet, right? So in the last class, I think I have not mentioned that every convolution operation, after every convolution operation, we will be having one more operation, that is non-linearity operation. Okay, and which non-linearity has been used in AlexNet is ReLU. ReLU activation function has been applied, non-linearity function has been applied on top of convolution operation. Okay, with that, let's start with today's session on VGG net. We do have two types of networks, VGG networks. One is VGG16, the other one is VGG19. The name itself suggests that in VGG16, it will have 16 number of layers. So it is much deeper as compared to 8 number of layers that we discussed in yesterday's session, that is AlexNet. Okay. Now, in today's session, we will be discussing VGG16. In particular, VGG16 has 13 number of convolutional layers and 3 numbers of fully connected layers. 13 plus 3 comes out to be 16. Okay, with that, let's start. What is the size of input layer? Size of input layer is 224 cross 224 cross 3. Depth of the input image is 3. Okay, and we will be having we will be applying 64 number of kernels, and size of each kernel is 3 cross 3. Okay, and depth again, depth of the filter will same as depth of the input. So assuming the input layer, input image has 3, so filter, if you consider filter depth, it will comes out to be 3 only. And the stride rate is 1, and I might not have mentioned in the slides, but padding is equals to 1. Okay, with that, when we put when we need to compute the output volume, we have used this particular formula in yesterday's session as well. So how do I compute width and height of the output volume? Width is computed using this particular formula, height is computed using this particular formula, right? So when I place, in case of W1, when I place 224 and width of my filter is 3 and padding is, I've taken it as 1. So you can cross check with all these values. 224 minus 3 plus 2 divided by 1 plus 1 comes out to be 224. So this is the width of my output volume when I apply the first convolution operation. Similarly, height can be computed with while placing the variable values. You will get the height as 224. Why the depth of the output volume is 64? Because sorry, because we have applied 64 number of filters. Hence, depth of the output volume comes out to be 64. Okay. So now, what is the output volume here? 224 cross 224 cross 64. I obtain when I apply first convolution operation with this filter size and these many kernels. With this, intentionally I have left this as blank. I will give 2 minutes of time. Do try to compute number of parameters, number of learnable parameters which are required. Okay, for this first convolution operation. I will give 2 minutes of time. Please kindly compute this. We will compare at the end. We will be comparing all the required number of parameters for with respect to each of the convolution operations. Okay, we will discuss. Okay, good. Yes, it comes out to be 3 cross 3 cross 3 plus 1 multiplied by 64. Why should I have not mentioned in my slide? At the end, I have mentioned all number of required learnable parameters with respect to each of the operation. But I can discuss with you how it has come, right? So we do take filter size. It is 3 cross 3 and depth of the filter size is also 3. So 3 cross 3 cross 3 plus 1 for bias value I will be adding for with respect to each of the kernel, hence plus 1 multiplied by how many kernels that we are applying. Here we are applying 64 number of kernels. So when you do this 3 cross 3 cross 3 plus 1 multiplied by 64, so you will obtain 1792 as your answer. Okay, this is the result of first convolution operation. So let us move to the next layer and let us see what is there in the VGG 6 architecture. What is the next layer? The next layer is also the convolution layer. That means after first convolution layer, they have applied the second convolutional layer only, right? So they have introduced second layer as convolutional layer. Again, they have applied 64 different kernels and filter size here is 3 cross 3. Okay, depth of this particular filter, depth of the filter at this particular operation for this particular operation will be taken from previously depth. That is output of this output of first convolutional operation, that is 224 cross 224 cross 64 will act as an input to my next convolution operation, correct? So here I need to see the depth here is 64, correct? Hence, I will be using this filter 3 cross 3 cross 64 and I will be applying convolutional over the output volume that I obtained with respect to previous convolutional operation. Okay, with that, I will be getting the output width as 224 only. Even height also will remain same, 224. Depth will also remain same because we are applying 64 different convolutional. Uh, we are applying 64 different kernels, filters for this particular convolutional operation. And again, padding I have not mentioned in any of the slides. Stride rate equals to 1, padding equals to 1, whereas filter size, it remains same throughout the convolution operation, that is 3 cross 3 only in VGGNet. Okay, with this information, again I have left the next slide as blank. You need to compute number of parameters which are required for this particular operation. Again, I will give you 2 minutes of time. If you need, you can refer the slide. Okay. Okay, that's correct. 3 cross 3 cross 64 by 64 because previous depth is 64. So I will be taking filter depth as same as the previous step. Okay, 3 cross 3 cross 64 plus 1 multiplied by number of kernels that we are applying. Yes, it is correct. Let's move to the next layer and let's see what is the third layer they have introduced in VGG 16. That is max pool. Okay, so pooling layer they have applied, and in particular they have selected max pool, right, with a stride rate as 2, and they have taken maximum of 2 cross 2, maximum pixel value of 2 cross 2. That means they will be keeping 2 cross 2 window size on each of 4 images of the input, and they will be extracting the maximum value out of that. So approximately it divides the height and width by 2. Okay, so it comes out to be 112 multiplied by 112 multiplied by 64. Correct? So I will pause here. Now again compute the number of required parameters for this particular layer. Learnable parameters. It comes out to be 0. Yes, it is correct. Because we are not applying any sort of convolutional operation, hence no need to have any sort of kernel values, right? Filter values. We are only taking like out of 2 cross 2, we are taking the maximum, we are retrieving the maximum value, hence no need to find any of the parameters. So number of parameters for the third layer, that is max pool layer, will remain 0. So let us move to the fourth layer. Fourth layer is the convolutional layer. Convolutional layer, again 3 cross 3 filter with padding 1, and number of kernels that we are applying here are 128. Okay, with this information we can compute width and height will remain 112 and 112. Depth will be 128. Okay. Again, I think no need to repeat the explanation. It is quite easy to understand from now onwards, right? So again, before moving to next layer, let us try to compute the number of parameters which are required. Number of learnable parameters again. Compute. Okay. Yes, it is very much correct. Next layer, again 3 cross 3, we will be using filter size, padding 1, 128 kernels. Again, we will be applying, again, we will be obtaining width, height, and depth as 112, 112, and 118. Can you now compute the number of parameters for this particular convolutional operation with respect to this layer? Yes, very much correct. It's correct. So it should be 3 cross 3 cross 128 plus 1 multiplied by 128 number of kernels. Correct. The next operation here is max pool operation. Again with 2 cross 2 with stride rate as 2, we will be able to reduce the height and width to 56 cross 56 cross 128. Number of parameters, no need to compute now onwards for max pool layer because it will remain 0. As such, we are not using any sort of operation. We are only extracting the maximum value out of it. So next operation for in VGGNet is convolutional layer. Again, we will be applying convolutional operation, and with the same information, that is 3 cross 3 filter size, padding equals to 1. When we apply 256 different kernels on the input image for this particular convolutional layer, is whatever output that it has been generated using the previous layer, that is using this particular layer. So input to next layer is 56 cross 56 cross 128. So with that information, okay, we will be able to compute width, height will remain same because here we have introduced the padding, and depth of the output volume of this particular layer of this particular operation will become 256 because we are applying 256 kernels. With this information, try to compute number of parameters which are required. Okay, it is very much correct. How you have obtained, can you write down? Okay, well, it's correct. So next operation is again convolutional operation with the same information, that is filter size as 3 cross 3, padding as 1, with number of kernels 256 number of kernels we will be using. So when we compute width, height and depth of the output volume after this convolutional operation, it comes out to be 56, 56 and 256. Okay. Okay, try to compute number of parameters required for this layer, for this particular operation. Am I audible? Here I have paused. Okay, fine. Very much correct. Yes, correct. So let us move to the next layer in convolution in VGGNet. That is again, we are going to apply convolution operation with this 3 cross 3 padding as 1 to 56. We are going to get the same convolution, same height and width as the previous layer. That is 56, 56. Depth will remain as 256. Okay. Compute number of parameters for this layer. Compute the number of parameters for this layer. Set the input depth, and you will take the depth of kernel as same as depth of the input for this particular operation. It should be 3 cross 3 cross 256 plus 1 multiplied by 256. Correct? Let us move to the next layer, that is max pool layer. Again, we will be applying stride rate as 2 with every 2 cross 2 elements. Okay. With this, my input 56 cross 256 will change to after when we apply max pooling operation, it becomes 28 cross 28 cross 256. And again, number of parameters, when we apply third max pool layer, it comes out to be 0. The next layer in VGGNet is convolutional layer with the same information, but here number of kernels, it's been increased from 256 to 512. Okay, in the previous layer we have used 256, but in this particular layer number of kernels that we are going to use are 512 kernels. With this information, the newly or the output volume for this particular operation at this particular layer is 28 cross 28 cross 512. When you compute the number of parameters here, I will only need to consider the input depth. Input depth we have just now considered it as 256. Yes, it is 256. So it should be 3 cross 3 cross 256 plus 1 multiplied by 512. Someone has computed it already. It is correct. The next layer is again convolutional layer. Okay, input is this, that is input is whatever input of the previous layer, that is 28 cross 28 cross 512 is the input for this particular convolutional layer, and with a number of filters 512, I will be applying 3 cross 3 filter, right? So output volume will become 28 cross 28 cross 512. Okay, with this information, just try to compute number of parameters required for this particular layer. Yes, very much correct. Let us move to the next layer. Again, convolutional layer. We are going to apply the convolutional layer, and here input filter size is 3 cross 3. Okay, and input for this first 28 cross 28 cross 512, and number of kernels that we are going to apply are 512. So output volume comes out to be 28 cross 28 cross 512. It's easy to compute the number of parameters. 3 cross 3 cross 512 plus 1 multiplied by number of kernels that we are applying during this particular convolutional operation. Okay, so after this we are going to apply the fourth max pooling operation, and with this 2 cross 2 with stride rate as 2, we are going to get, when we apply on this 28 cross 28 cross 512, we are going to obtain 14 cross 14 cross 512 as my output volume. Okay, so with this the next layer is again convolutional layer. 11th convolutional layer we are going to use with 3 cross 3 as filter size, padding as 1, with 512 different kernels we are going to use for this convolutional operation. With that, my output volume becomes 14 cross 14 cross 512. And you may compute number of parameters required for this operation. Yes, very much correct. Let us move to the next one. That is again convolutional operation followed by one more convolutional operation, 3 cross 3, filter size, padding as 1, and you can see in all the previous slides this information remains same. Okay, the same kernel size we are going to apply for with respect to each of the convolutional operation. Correct. With this information, the output volume becomes 14 cross 14 cross 512. Okay. Compute the number of parameters required for this particular layer. it should be 3 cross 3 cross 512 plus 1 multiplied by 512, because previous like input to this particular operation is again depth is 512, so I will be using same depth as my input, right? So kernel depth will remain same as my input, that is 512. Hence 3 cross 3 cross 512 plus 1 multiplied by 512, followed by one more convolutional operation with this information 3 cross 3 cross 512 filter size. Okay, padding as 1, 512 different kernels. When we apply, we are going to get 14 cross 14 cross 512 as my output volume. You may compute the number of parameters which are required for this particular operation. It actually comes out to be same as the previous one. So it is 3 cross 3 cross 512 plus 1 multiplied by 512. The next operation that we are going to apply is max pool layer. Here we are going, this is the fifth max pooling operation that we are performing on the given input image. So 2 cross 2 with stride rate as 2, my output volume will reduce by half. So 14 cross 14 cross 512 will become 7 cross 7 cross 512, right? After this, we are going to apply fully connected layer. Before this, what I need to do is I need to flatten this one, that is these many pixel values, right? 7 cross 7 cross 512, so they are not in one dimensional 1D space. So what I need to do is I need to convert this into 1D vector, right? So when you elongate this to 1D, or when you convert this into 1D vector, okay, first you need to convert, that means you need to flatten it and later on apply the first convolutional operation. So how many neurons in the flattened layer that you will get? You will get these many neurons, 7 cross 7 cross 512. Okay, so those many neurons will be connected with 4096 neurons in the fully connected layer. Okay, first fully connected layer has 4096 neurons in it, which is same as fully connected layers number of neurons in case of first fully connected layers of AlexNet. Okay, this is second fully connected layer. Again, it has 4096 number of neurons in it. The third fully connected layer, definitely it is an output layer which uses softmax function. So it has 1000 number of different neurons in this particular fully connected layer. Okay, do you get that? First, this 7 cross 7 cross 512 will be connected with 4096 neurons. This 4096 neurons will be connected with these 4096 neurons, and these 4096 will be densely connected with these 1000 neurons. Okay, so how do I compute the number of parameters for this fully connected layer? You all know, we have already discussed in the previous class, that is 7 cross 7 cross 512 multiplied by 4096. Okay, number of neuron, these many number of neurons are connected with many number of neurons in fully connected layer. Hence 7 cross 7 cross 512 multiplied by 4096 plus one bias term for each of the neurons in fully connected layer. Okay, so plus 4096 will give me number of parameters for this particular first fully connected layer. In a similar way, this first fully connected layer will be connected, 4096 will be connected with 4096 of next fully connected layer. Hence, when I compute number of parameters, it should come out to be 4096 multiplied by 4096 plus 4096 for the bias need to be added. Now, for this fully connected layer, when I need to compute the number of parameters which are required, so how do I compute? Again, 4096 multiplied by 1000 plus 1000 will give me total number of parameters which are required for this particular fully connected layer, that is the output layer. right? With this, let us try to get the brief overview of the VGG net, VGG 16 architectures. So you have done this computing number of parameters. It is just for illustration. I've listed them. Okay, first operation is convolutional operation 224 with input as 224, 224 and 64. Okay, this is the output that I am going to get when I apply the convolution operation on 224 multiplied by 224 cross 3. Okay, so this is the output shape I will get when I apply convolution operation on 224, 224, 3. And these many number of parameters which are required, which need to be learned for this particular first operation, that is convolutional operation. So it comes out to be 1792. In a similar way, when you in the second convolution operation 224, 224, 64 will become as an input for the next convolution operation. It will generate when you apply 3 cross 3 filter on this particular input, it generates 224, 224, 64 as its output, and number of parameters required you have already computed by yourself. It comes out to be this much. Okay, that is 36,928 number of learnable parameters which are required for this particular operation, that is convolutional operation. Like this, I have listed all the convolutional and pooling layers and as well as fully connected layers. You can see in VGG net, we do have 13 different convolutional operation, 5 different max pooling operation, and definitely I will be flattening this so no parameters are learned for this particular layer. Flatten the layer. We are only elongating this 7 cross 7 cross 512 to 25088. We are converting this to 1D vector. Okay. So number of parameters again as same as max pool layer. Max pool layer also we are not performing any specific task, so it becomes 0. Here also it becomes number of parameters required are 0. Okay, followed by 3 densely connected, fully connected layers. Okay, with 4096, 4096 and 1000 number of neurons. Okay. Now, why VGG 16 is called as VGG 16? Because of 13 different 13 number of convolutional operation and 3 number of fully connected operation. And why we are not considering max pooling operation or as layers? Because we are not going to have any like learnable parameters. Hence, we only require to consider or count those number of layers which are like which need to be learned, okay, or whose weights need to be learned. So we already know that convolutional operation as well as fully connected layers, they need the weights to be learned, right? Hence, we only consider convolutional operation, 13 convolutional operation, and these 3 densely connected, fully connected layers. Okay, so 13 plus 3 comes out to be 16. So this completes the VGG 16 architecture. So just a small homework from my side, today's assignment. So what you do is you just try to get uh, what we have in VGG 19 architecture. We must be having 3 more layers, and you just try to get what are those 3 different layers. Okay. And this is the reference that I have referred for today's session. With this, I will stop. I've already stopped sharing. So it's the I've done with today's session. If you have any kind of queries, you may ask. In tomorrow's session, we will be doing one more architecture, And from next day onwards, we will try to, for next 2 days, we will try to implement, or we will try to use the already existing models, okay, that are like either AlexNet or PGGNet. We will do it, we will try to use the already existing architecture in for our given examples, okay. Because all these architectures have been trained on a very huge data set, large data set. So already many parameters have been learned. So we will make use of those already learned parameters, and we will try to import, sort of importing that we will do. And we will try to analyze our own, we will apply those architectures for our examples. Okay. Any queries you may ask? Okay. Sakshi?
Yes,
I've
ma'am.
done, I've done with today's session.
Okay, ma'am.
Thank you.
Thank you so much. Still, is there anyone having any doubt? Thank you so much, Madhavati ma'am. I don't think there are more doubts then.
Thank you, Sakshi. Thank you,
Thank
everyone.
you, ma'am. Thank you, everyone. Just wait for a few minutes. I'll share the attendance link in the chat window. Just wait for a minute or two.